Okay, so going over the whole review package, remember greatest area is always in the shape of a square. So for this number 1 question, instead of wasting time drawing different dimensions, I know to straightforward go for the square one. Greatest area or minimum perimeter, always it's a square. What's the 3D shape of a square? Cube, right? Okay, so a cube or a square would always give you the greatest area. Number 2, we talked about it already yesterday. So given the, you can do, make sure when you do the test tomorrow, area, perimeter, it's asking you for both. So make sure on the test you're solving for both, okay, not just one. Whenever you're not given a side, what do you have to do? Pythagorean theorem, just like right here. So whenever you don't know something, do Pythagorean theorem. I gave you guys the hint. Watch the units. So on the test, I'm not gonna give you that hint. You have to be very careful with reading the diagram. Right. So this, I know my first step was to change it to 6 centimeters. By the way, the conversions, you do need to memorize the conversion for metric. Right. Number 3 right here, drawing the net. Since this is an octagon, when I open it up, I see a net with 6 different triangles as the sides. In the middle, the hexagon, I can also divide it up into 6 triangles. Right? As I told you already, one of the questions on the test will be a communication question explaining your steps of this. Okay, so just to go over the steps again really quickly. 1, open it up to draw the net. 2, find the height of the triangle by using Pythagorean theorem. 3, calculate the area of the triangle and then times it by 6. So that will give you your total area for the side triangle. 5, divide the hexagon into 6 equal triangles and find the area of each, then times it by 6. So you get the whole area of the hexagon. And then last step, add up all 12 triangles to get your total surface area. Okay. So there's your little summary. There's 4 free marks for you guys if you guys remember those steps. Okay. So I don't want you guys to like memorize the steps of what I just said. It's understanding the question. If you understand the question, you understand what to do, then you're just explaining what you're doing. Okay. So that was number 3. Number 4. This one, when you're asked how much fencing, it means you're looking for perimeter. Okay? You have to understand what the question is asking you. So you're asked how much fencing. So in this trapezoid, how many sides are in this trapezoid? How many sides? 4, right? So at the end, I should be adding 1, 2, 3, 4 numbers. Problem is, I don't know this length right here. And so, Pythagorean theorem. Okay, what I have to find out first is this little bit right here. So when I do Pythagorean theorem, I'm looking for the side length, so I'm subtracting. Right? So 16.3 squared, take away 16 squared, I get a number, square root it, I get 3.1. Okay, so this little bit is 3.1. Why do I need this 3.1? Because I need to figure out how long this part is. Okay, so if this whole thing is 39, this part is 3.1, this top part is 24, that means what's left is this 11.9. So now that I know this is 11.9, I know the height is 16, I can do Pythagorean theorem to figure out the hypotenuse. So when I do that, I get 19.9, add up my 4 sides, boom, 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 and then I get 99.2 meters. Perimeter, meter, right? And number 5. Okay, number 5 is pretty tricky. Okay, so what you want to do is work with the information that you have. So you're given the surface area is 440. So you want to write the equation for surface area of a square-based pyramid. They did tell you what it is, square-based pyramid, surface area. So this is the formula you want to start up with. Okay, so you know area is 440. You know that B is 8, 2 times 8 times S. And then this is just an algebraic equation. 440 equals 64 plus 16S. Do not add these 2 numbers. You cannot add 64 and 16S. Instead, move the 64 over by subtracting and then dividing the 16. So S is 23.5. Right? How many of you stopped here and said this is my final answer? Okay. Why is this not your final answer? Miriam?
It says final
Height, right. What does S stand for again? Slanted height, right. So what you just found was this, but your height, you still don't know. So whenever you don't know a dimension, Pythagorean theorem. You're looking for height, so you are subtracting. So when you square it, subtract it, square root it, you get 23.2 centimeters as the height. Okay, so this is a little trick as well. Whenever you're looking for a height, you're always doing the subtraction. Whenever you're looking for the slanted height, you're doing the addition. Okay? So I'll write that down at the end as well, so that you guys remember it better. Okay, number 6. Okay, so as at the beginning, just like number 1, we said that a square gives the greatest area, and then Vincent, you said what's the 3D shape of a square? A cube, right? So a cube will always give you your greatest surface area, greatest volume as well. So here, the surface area formula for a cube is S equals 6S squared. I know surface area is 210, so I divide that by 6, I get 35. Opposite of square root. So when I square root it, I get 5.9 centimeters. Okay. How do I know to use the surface area? Oh, sorry, I put the wrong. Yeah. How do I know to use the surface area formula in this question? Because of my unit right here, centimeter square. So that's how I know. Okay, the 210 is the surface area. Okay, and so that's why I want to use the surface area formula. That's why I keep saying to you guys that why it's so important for you to know the units. Okay. And then B is just the same thing. So instead of 210, it's 490. So I didn't do that. Okay. When I came around to do the homework check, I think some people had trouble with these too. So there you go. Okay. Okay. On the back. Okay, so looking at this diagram, what is the very first thing I should do looking at just the diagram? Conversion, right? Okay, so meter, this is in meter, this is in centimeter. So I need to change one or the other. So I think this is easier to change. So 0.05 meter is the same as 5 centimeter. So I change that. Now I can do my formula. Find the volume of the cone. Remember, you are given the formula sheet. Okay, so and it's one thing to give you the formula sheet, it's another that you know how to use it. Okay, so for cone volume, I'm going to use this one or this one. Does it matter which one I use? No. Okay, so it doesn't matter. Just if this looks too confusing for you, just use the last one. Okay. This reads the same as just 1/3 pi r square h or pi r square h divided by 3. Doesn't matter. Both are the same. So I personally like to use the divide by 3. So like calculate everything and then divide by 3. But what's the problem? What's the problem right here? I don't have height. And when I don't know a dimension, I use Pythagorean theorem. Since I'm looking for height, I'm using the subtraction one. Okay, so 10 squared, take away 5 squared, and then square root it, I get 8.7. That's my height, not the 10. Okay, and then when you sub it in, you get 227.7 centimeter cubed. For all of the answers, I use 1 decimal place. On the test as well, just use 1 decimal place. Okay. So the only trick to this question was just remember, if it's slanted, that's the slanted height. If it's vertical, that's the vertical height. Okay. Number 8, calculate the volume of the house shown below. So I want the volume. So I have to do the building part first, the rectangular prism, plus the volume of the rectangular pyramid, right? So for the here, okay. So for the rectangular prism, I have length times width times height. So I just multiplied that, and I get the 120. Again, change the unit. And then for the prism, some people were asking about that. Okay, if you take a look at the formula sheet, this one is a square base pyramid. Is this a square base pyramid? No, because this is 8 and 6. A square base would mean it's like 8 and 8 or 6 and 6. So if you look at here, that's why it's a B square, because this was a square base. But if it's not a square base, it's just the area of the base times the height. What shape is the base here? Is that rectangle. And what's the area of a rectangle formula? Length times width. And so it's just simply length times width times height divided by 3. Right? So even though the formula sheet didn't give you the formula for a rectangular base pyramid, the logic is there. It was area of the base times height divided by 3. So length times width times height divided by 3. So the 6 times 8 times the 0.8 divided by 3, you get that. Add the two volume together, you get your total volume. Okay. Okay, I see some of you are copying down the answer, so I'll just give you guys a second. Okay. I'm just like, okay, good. Nobody has their phone out. Good. All right, number 9, calculate the volume and surface area of the cylinder. Okay, so remember, this is a straightforward question. You will get some straightforward questions on the test as well. So these ones should be easy marks for you guys, because all you're doing is substituting numbers into the formula. One problem that I've seen is people see I ask them volume and surface area, but they only do one of them. Okay, so make sure you read the question carefully. So pi r square h, that's the volume formula for a cylinder. Notice I always like to start off with the formula. Try to do that. It is a very good habit. It minimizes the careless mistakes. Okay, so pi 3.14, radius is just a 4 square, and then the height is 10. Multiply everything together, you get volume in meters cubed. Surface area of this one, this is your formula. So 2 times 3.14 times r squared plus 2 times 3.14 times radius, which is 4, height, which is 10. Add them together, you get that. Be very careful with bed mass. So do this on your calculator first, do this on your calculator second, and then add it together. Right? Otherwise, your calculator may give you a different answer because they don't know bed mass. Okay. Okay. All right. Number 10 right here. So number 10, there were quite a few steps with this one. Calculate the length around the field. Length around the field. What are you looking for? Perimeter. Excellent. Okay. So looking at this, I see a semicircle. I see a straight length. I see another semicircle and a straight length. What does two semicircle make? One circle, right? So you're doing the circumference of a circle, which is pi d, 3.14 times 30.19, because that's your diameter. Okay, and then I get the circumference of the circle, 97.1. So this part and this part. So to find the perimeter, I'm just adding the top and the bottom. Do I need to add that 30.91? Isabel? Because that's correct. Why do I not add the 30.91? Because it's not on the outside. Perimeter is just the outside. This is in the inside. You don't add it. Okay, so just the circle with the two straight line, and I get that. Okay. If Amanda runs 625, how many laps does she do? Oh, and my computer froze. Ah, crap. So the video is Okay. So then I just divide the 625 with the 196.2 because that's the perimeter of the whole lap, okay, of one lap. So when I divide it, it means she went 3.2 laps. Okay. You added the 30.91? Possibly. Yeah. Okay. Common mistake. Okay. And then now they want to resurface the field, cover it with new grass. So what are you looking for? If you want to cover the inside with new grass, you're looking for area. So area of a circle. And what is the shape in the middle? Rectangle. So length times width. So area of a circle, area of a rectangle. Put those dimensions in and then add it together to get your total area. Right here, what is my radius? How do I figure out what the radius of this circle is? Miriam. Right, because this 30.91 is actually your diameter. So if half of it, that will give you your radius, which is 15.5. Right? So this one is a good question. It's doable. It was just a few steps, a few extra steps. Okay. So this one is a little tricky. Number 11. Your bag of cubes holds, so your bag holds 21 sugar cubes. Okay. And the total volume is 168. So if I use the 168 divided by 21, I get 8 centimeter cube. But what is this 8 centimeter cube? What does it represent? Isabel? Volume of each cube. Perfect. Right, so now that I know the volume of each cube, volume, cube, I'm using the volume formula. So when I substitute it in, so for opposite of square is square root. What's opposite of cube then? Cube root. Perfect. Okay. Let me show you guys how to do that on a calculator. Okay, so you actually do have that cube root button. It's this one right here. So you see that little X? So you would do 3 second that. So now you see how it's like a cube root on the outside, and then you do the 8. So you get the answer 2. Okay, so that's how you use your calculator. What is the number on the outside for a square root? Tricky question. 2. That's right. Okay, so we are just lazy. So when we do the square root, we mean the second root. Okay, so if I do this, it's the same thing as just using the square root button. So for example, 2 square root 25, I get 5. Okay. This one. So I have a pill. So use your imagination for a pill. It's a 3D shape. What 2 shapes make up a pill? Cylinder in the middle and a sphere, right? The other 2 ends. What do you call a half a sphere? Not semi-sphere. Not semi-sphere. Think geography. Huh? Half a sphere is called a hemisphere. Hemisphere. So 2 hemisphere makes a full sphere. So in this case, you are adding the volume of a cylinder and a sphere together. Why I didn't continue on here is because the government decided to make some changes. Okay, so on the back right here, some people left it blank because you didn't know what to do. Okay, so let's pay attention here. Good job, Kaden. Okay, so you have an isosceles triangle right here with the sides 12. Since it's an isosceles triangle, if the base is 10, that means each of these are 5. You want to find the height of it, so I have to split it up into this right angle triangle. I'm looking for height, so I subtract. Okay, so square it, subtract it, square root it, I get 10.9 centimeter. That's the height. Okay, number 2 right here. I like this question because this ties in to our last unit with coordinates. Okay, where did I get this 12 from? Where did I get this 12? Logan?
Space in between 16 and 4.
Yeah, 16 minus 4, that's 12. This is my run. All right, how do I get the 5? Oh. All right, 12 minus 7. This is my rise. Rise over run, x2 minus x1, y2 minus y1 over x2 minus x1. There we go. Right? And now I'm just looking for the area, which is base times height divided by 2. And so my area is 30. It's not centimeter square. I just throw that in. I never specified what the unit was, but I just wanted you guys to remember area is always square. Jaden.
How much time is on it? The whole thing?
I'll talk about it. Okay. Yeah.
Oh, why is the unit centimeter?
Oh, I just threw that in. Yeah. I would specify. Like I will say that this is on a centimeter grid or something.
Can you say unit square if there's
Yeah, you can say unit square. Okay, number 3, Daniel. He's riding a bike. So let's say this is Daniel right here. He's going west, which means I go left. And then I go north, which means going up. Find the distance, diagonal distance. I'm looking for the hypotenuse, so I'm adding. Why did I put a S here? Okay, so what does S stand for again? Slant, right? The slanted height. So I want you guys to get used to the idea. Whenever it's a diagonal, it's a slanted height, and whenever it's a vertical line, it's your vertical height. So that's why I use that S right here. Square root it. I get the 27.7 kilometers. Okay. Last 2 question, conversion question. These right here. Okay. Will I give you guys this?
No.
No, you have to memorize it. Will I give you guys this? Yes, because I don't expect you guys to remember these numbers. So I want to convert from kilometers to miles. What do I do? Kilometers to miles. Perfect. I'm going from metric to imperial, so I'm timesing by 0.6214. Okay, and so 120 is 74.6 miles per hour. Now, some people on the test, they show me this, but then they never answered the question. The question was he speeding? Yes, that's answering the question. Okay, so you'll get marks for this, but still, you lose mark for not answering the question. All right. Last one, also a conversion question. So remember, speed is distance divided by time. So 100 meters divided by second. So John was running at 6.7 miles per meters per second. Right? Here, I want to change from yard to meter. Yard to meter, what do I do? Yard to meter. I'm going from imperial to metric. Austin. Right, because I'm going from imperial to metric, I'm dividing. So divide by this ratio. So dividing it, I get that divided by 16 seconds, so 6.9 meters per second. So again, answering the question. What is the question asking? What is the question asking? I showed all this work, but I never answered the question. Marco, right. So who was faster? Marco was faster. Right, so make sure you answer the question. Right, so that's the review package. Here's some little hints and things for you guys. All right, so I drew this diagram out, Pythagorean theorem. Whenever you're looking for S, it's always the adding one. Whenever you're looking for height, it's always the subtraction one. And the base, most of the time, it's half the base. Okay, so you do have to divide it by 2. Okay, so keep this in mind. It does make your calculation easier to understand. Yeah, it is exactly that. A squared plus b squared equals c squared. Because this is the height, this is the slanted height. And in this unit that we're doing, this formula sheet, everything is S and H and S and H and B. Alright, so if I do A, B, and C, you guys will not know what to use.
That one you know is in the test. The input reading is same or
Yeah.
same.
Yeah.
Same.
Yes. And it's a 100% same on EQAO as well. So exact same formula sheet. That's why I give you this one, because I want you guys to familiarize with it. Question.
Can you memorize all of this? Like, you're gonna need to let us fill it out.
So this right here. You do need to memorize the order of this, but it's easy as long as you remember the order, because it's just by tens, right?
We memorize to help us or because there's a question on it.
Memorize to help you guys with the conversion.
Oh, but there's no like question on it, right? Like, can you write KHD?
No.
No.
All right. So, what abbreviation, like what acronym did you guys come up with for this order? Anyone want to share theirs? So this morning, class said King Henry don't usually drink chocolate milk. It works. Maria, what do you use?
I was gonna say Pat Harrington doesn't usually drink coffee much.
Okay, sure. But that seems very hard to remember. But if it helps you memorize it, by all means. So, but you do need to memorize this chart. So, for example, if I want to go from metric to millimeter, meter to millimeter, I would have to times it by 10, 100, 1,000. So times it by 1,000. Similarly, if I want to go from decimeter to decameter, I'm dividing by 100 because it's 2 steps. All right, so this you need to memorize. This I will give you, but all you have to remember is going from metric to imperial, you're timesing. Going from imperial to metric, you're dividing. Okay. I will also give you this exact formula sheet. All right.
Can you re-give it to us?
I will. Well, if you have yours, I will like to save paper. Right? If you take a look at the formula for a cone and a cylinder, what do you recognize? Between a cone and a cylinder?
It's pretty simple.
Okay, how similar? More specifically?
Similar that they both have pi r square height, just that for the cone you have 1/3.
Right. What does that 1/3 mean then? Like it's yeah. Divide by 3. So if I fill this up with water and pour it into the cylinder, how many cones will it take to fill up a cylinder? Maria? 3, right. Similarly, if I pour, so let's say this cylinder is full of water and I pour it into the cone, how much did I empty? 1/3. Excellent. So you see how the wording, 3 and 1/3. So depending on the question, EQEO love to ask this type of question. So remember, you could say this is 1/3 of a cylinder, or you can say this is 3 times a cone. Right.
Do you visualize it? Like if you put like 3 cones, like
yeah,
kind of makes a trapezoid.
But we're talking about volume. Oh. Yeah. So good point. Let's talk about surface area then. Okay, how many actually not surface area yet. Let's do okay, how many square base pyramid does it take to fill up a cube? A square base pyramid with a cube. Yeah.
It's like 3 and then to the power of 2.
I'll ask that again. How many square base pyramid does it take to fill up a cube? 3. That's it, 3. All right, because it's divided by 3. Right? Let's talk the surface area now. Oh, actually, here, one more. Triangular prism in a rectangular prism. How many triangle base prism does it take to make up a rectangle base? Yep, 2, because it's the 2 divided by 2. Right? Let's talk the surface area now. So as Jaden was saying, this formula is for the whole surface area of the cone, including the bottom. Now, if I don't want to paint the bottom, how would my formula change? If I don't want the bottom, how would my formula change? Yep.
You wouldn't put 2. No, you wouldn't put like, you would do minus pi r squared afterwards, and then you get the total for that.
Okay, or
And pirates.
yeah, just ignore that part. So that part is the circle on the bottom. So if you just use this, that gives you the lateral surface, just the side. Okay. What about this one? If it's an open top box, what's the surface area of this open top box? How would it change?
To the surface area instead of 6, you multiply.
Perfect. That's it. That's it. All right. This one. Let's say I don't want the circles. I don't want the top. I don't want the bottom. How would this change? Yeah. Yeah. So pi. Oh no, not just pi RH.
We just cancel out 2 pi r squared and just have
2 pi RH. You will still have that 2 because that 2 is part of the lateral surface. Yeah, so you would just take away that. You'll still keep that 2. All right, this was a tricky one. This is a tricky one. What about this rectangle-based prism with no top? How would this formula change? George, how about you? All right, I have a rectangle-based prism, but no top. How would my formula change? What do you think I should do?
Subtract it.
Subtract what? Yeah, you could.
The rectangle. Like calculate it as if it had a rectangle, then subtract the rectangle.
Perfect. This, if you open it up, it's just 6 rectangles. All right, so do not just take out that 2. If you take out that 2, that means there's only 3 sides. All right, as you know, if there's no top, then the easiest way is to subtract that top rectangle. So subtract the length times width up here. Okay. Or you could do the area of 5 rectangles and add it together. You could do that too.
Can't you just do those 2 W H and RH and close the bracket and then just do plus?
Yeah, you could do that as well. That's an L, length times width. So width times height plus length times width plus length times height. Okay, so that's the review for today.